Troubleshooting BGP routes. Well, we're starting off with our familiar BGP topology, but this time instead of focusing in on the neighbor relationships, we're focusing in on the routes themselves. We already have the neighbor relationships established. I'm going to type in show IP BGP summary. And we can see here that we have two neighbor relationships. They've been running for a little while. We've got our prefixes have been received. Now let's take a look at the routing table. Show IP BGP. I said routing table. I meant to say topology table. Show IP BGP shows all of the routes that your router has learned about, both the best, the second best, the third best, and so on. For example, take a look at this 153 right here. 153.110 was learned from two different sources. 150.111, which is this guy sitting right here. And we've got it learned from 150.115, which is this guy sitting right here, right? Now notice only one of those ended up in the routing table, and it happened to be this one up here. That's what the little caret means, is yes, both of these are valid. That's what the star means. The caret means this one was chosen as the best, and that will be, if I do a show IP route, what I see in the routing table as the destination for 153.1000 or 00 right there. Okay, so that's how we can view our BGP routing table. Now, what about advertising routes into BGP? Well, there's a couple ways of doing it. First off is redistribution. I can go into router BGP and do a redistribute, and whatever the case is, whether it be static, whether it be connected, could be another routing protocol that I redistribute into. Typically, when you do redistribution into BGP, you're going to do some sort of filtering along with it, typically using a route map, because a route map allows you to not only filter what routes go into BGP, but you can also set what criteria go into BGP. So what the metric is, or what the weight of the route is, or what the local preference, all the different BGP attributes that exist can be set via the route map. Another way of advertising routes into BGP is by using the network command. However, the network command is very misunderstood when it comes to BGP. For example, you can see that right here in this network, I've got the local network 200.110, right? So let's just say we are a small little ISP that has taken that and is now going to carve that out and send it out to all of its clients or something like that, right? Well, I want to advertise that to all the upstream carriers so that they can advertise it to their carriers, and I can have a redundant network, right? Well, when I come to the network command, I might say, okay, well, I just want to come in there and do network. Well, I chose an odd network to do this because we would typically do it this way anyway. But you might type in network 200.1.1.0, right? Which is actually the right way to do it. But for instance, let me just do it a way that might be a way some might do it. Type in network 200.0.0.0, right? Because with the way the network command is traditionally used with other routing protocols, typing in network 200.0.0.0 means that anything starting with the number 200 is going to be chosen and used as a valid interface. Well, in the case of BGP, the network command is different. The network command only identifies routes that already exist in the routing table and advertise them via BGP. I always compare BGP like an application layer because it almost rides on top of other routing protocols, right? Well, in this case, it is doing just that. It's saying, okay, I'm going to advertise something that's already in the routing table to my BGP peers. However, when you type it in, it has to match exactly what's in the routing table. So this will actually result in nothing being advertised, even though there is a 200.110 sitting in the routing table. right? So instead, I have to do a network 200.1.1.0 exactly. Now, if I have any custom mask or anything like that on there, I have to type in mask and type in what subnet mask I'm actually using on that route. In this case, I'm going to put the Class C mask, which is no harm whatsoever. That will allow this router to advertise that to its peers. So let's come back now and do a show IP BGP. And there's my local route showing up in the routing table. It's got a weight of 32,768 because it is a highly weighted, a highly preferred route in my table. So if I do a show IP BGP neighbors, and let's just look at 150.1.1.1, and we'll look at advertised routes, I can see that this route is being included in the advertisements that are going up to that neighbor. We can do the same thing for 150.1.1.5 advertised routes. All these routes are going back out because, again, we're relaying these routes in between. Now, by the way, we may or may not want to do this because essentially what we're doing right here is opening us up to be a the term just slipped my mind. To be the proxy, the guy stuck in the middle. It's where you don't want to be, right? To where you're paying these guys for internet service, and they're going to start relaying traffic through you. There we go. That's what I meant to say. Relaying traffic through you to reach each other because essentially you're advertising the routes out. So, what else can we do with our routes? We might want to put on a filter, right? So the way we can do that is we can, well, there's 1,000 ways in BGPs to put on filters. I would say one of the quickest ways might be to use a distribution list. So for instance, I can go in and create an access list. Let's say access list, I'll just say 100, permit. Well, let's even go simple. Let's use a standard access list. Access list 1, permit 200.110.0.0.0.255, right? Now we'll go into router BGP 500, and I'll do neighbor 150.111, and I'll use a distribution list of 1, right? A distribution list just simply attaches an access list and uses it as a filter. So I'll say outbound. So the only thing I want to be sending each one of these neighbors is my network 200. And that way they don't see each other through me and thus won't use me as a relay and use my bandwidth that I'm paying them for to reach each other, right? So now I should be able to hit the up arrow and do a show neighbors advertised routes. Whoa, wait a sec. What's the problem? Anytime you do anything with BGP dealing with a filter, you've got to clear the BGP relationship. But I shouldn't say relationship. It depends on how you set this up. You can do hard resets or you can do soft resets. In this case, I haven't really set too much up, but let's just do a simple clear IP BGP star, and that should bounce all the neighbors and bring them back up, right? Once that takes effect, there we go, neighbors are back in play. I should be able to hit the show neighbors advertised routes, and after we give it a little time, it should show the only route that's being advertised now is the 200 network. Gave it a little pause to let everything catch up. Do the show command again. There we go. Now we can see the only route that's being allowed through by the distribution list is the 200 network, which is exactly what I want. The other way that I can go about it is, of course, using a route map. We can attach a route map to a neighbor. I'll do router BGP 500 neighbor, and I'll just type in any neighbor route map, and then you can type in whatever route map you'd like, and how you want to apply that. Do you want to filter that through inbound or outbound updates? Now, the beauty of a route map is it's unlimited. You can have as many lines as you want and do as many tweaks and twists as you want through that thing, and it's not just for route filtering. You can use it for that, but you can also use it to set any one of the BGP attributes in whatever way you want. That's what really makes BGP powerful, is the ability to use that route map. Well, what can go wrong with BGP routes? Well, first off, the network command. Just like I was showing you before, it has to match exactly what's in the routing table, otherwise it won't show up. Second thing is you might end up with next hop unreachable for the routes that you have in your BGP table. That's a weird one until you really think it through. Show IP BGP, you might say, okay, well, if they ended up here, obviously I had a neighbor relationship, right? And if I had a neighbor relationship, then I know how to get to the next hop. So how could the next hop in this table be unreachable? Well, let me show you. A lot of times with BGP, you have these neighbor relationships that are not directly connected, right? So let's just say we've got our eBGP relationship going up here to some domain, and then I've got a bunch of routers, going through here, here, and another BGP relationship coming out here to some other autonomous system domain, right? Now, you might peer these guys together using iBGP, right? That's what that says. And so the rule of iBGP says you will never change any of the BGP attributes in an iBGP session. Now, there's ways to bend, and it's kind of like the Matrix. Some rules can be bent, others can be broken. But in this case, it's not supposed to ever change the next hop value. So a lot of times routes will come in via this eBGP peer, advertise over all these guys to this guy with still the same next hop of this guy. And he may not have any idea how to reach the next hop of this guy right here. Now, there's a way you can tweak it. Like I said, some rules can be bent. And the way that you do it is by defining this neighbor statement with, and I'll show you the command right here. If you go into router BGP 500 and type in neighbor, whatever neighbor you want, next hop self is the command that you can type in there. And what that does is automatically replace the next hop of this guy with itself, which hopefully, if you obviously are forming a neighbor relationship, this guy should know how to reach. But that's how you can end up with a whole bunch of routes in your routing table that have an unreachable network address, is because iBGP doesn't change the network address. So you have two choices. Either use that next hop self command, or you can actually advertise that external link right there into your routing table. Because remember, default route can't be used to reach those external BGP neighbors. Route filter. Route filter, you just saw I used the distribute list, but you could use a route map. A route filter configured incorrectly could make BGP routes go very wrong. BGP split horizon can throw you for a loop. BGP split horizon applies to routes via iBGP. What the rule says is I will never advertise an iBGP route that I've learned via iBGP. Sounds weird, right? Here's diagrammally what it looks like. So this guy receives it via eBGP. That's fine. He advertises it to, let's just say this guy right here is running iBGP, right? The rule says I will not ever advertise that route to another iBGP peer. It keeps loops from happening. That's why it's there. BGP's only loop prevention mechanism is the autonomous system number. Every single time a route passes through an autonomous system, it kind of puts a little stamp on that route so that if it ever loops back around, and it will on a network the size of the internet, it goes, oh, no, no, you've already passed through this autonomous system. I'm going to block you and keep you from looping around the network. Well, because IBGP doesn't have multiple autonomous systems, right? It has this IBGP split horizon rule that says I can only pass it to one IBGP peer and then I'm done. So what you can have with your IBGP routes is a black hole if you forget about this rule or don't disable it or use it inappropriately. There's all kinds of things around BGP split horizon. You might want to check out the BGP series we have at CBT Nuggets to learn all about it. But that one can definitely throw your routes for a loop. Last one is a better path chosen via best path decision making process. You may think that you know which way the routes are going. However, there is a huge process. Let me bring it up for you right here. This is the BGP route selection criteria. So let's say you receive the route 10.1.1.0/24, and there's already 2 of those in the table. The BGP table, and it has to figure out which one it's going to end up in the routing table. Well, this is the criteria it goes through to make that decision. First off, it says I'm going to prefer the one with the largest weight, right? The Cisco proprietary attribute, the one with the highest local preference. Does this list look familiar by any chance? If you went through the route series or the BGP series at CBT Nuggets, it should. This is definitely one to know if you're working with BGP. Locally originated routes, shortest AS path. And by the way, you can draw a line right there in your notes. Those are the ones I would commit to memory because it solves almost all of the BGP routes. Once you go past that, you start getting down to random chance. I mean, you can see down at the bottom, the oldest route, the one that came from the router with the lowest router ID. I mean, essentially, it's rolling the dice to try and break the tie to see which of the routes, if it has duplicates, end up in the routing table. Well, those are the key elements you should understand when looking to troubleshoot BGP routes. I hope this has been informative for you, and I'd like to thank you for viewing.